Welcome to learn how to use the new JSON features in RAD Studio 10 Seattle release webinar. My name is Pawel Glowacki. I'm working for Embarcadero as EMEA Technical Lead for Developer Tools. And today, during this webinar, we are going to cover the new features that were introduced to support JSON in Delphi 10, C++ Builder 10, and RAD Studio 10 Seattle release. We are going to start with a small introduction to JSON, what it is, why it is so popular in the world of programmers and system integrators, and then we are going to go specifically into the JSON support in RAD Studio. We are going to discuss existing JSON support that was there in RAD Studio for a number of releases now, but we are going to focus exclusively on things that were introduced in RAD Studio 10 Seattle. There are new ways of writing and reading JSON, new support for BSON, the binary JSON, also brand new support for MongoDB open source NoSQL database, which is very much related to JSON because the internal data representation of MongoDB is JSON, and RAD Studio 10 features a lot of new types and support specifically for working with JSON in MongoDB. We are going then to move into how you can extend RAD Studio 10 using custom components. I'm going to demonstrate two custom components for working with JSON, the tJSON document component and the working with it tJSON tree view component. And then we are going to finish with a presentation of a custom utility application for viewing JSON coming from the URL, coming from the clipboard, from the file. And then this webinar will be followed by the session of live Q&A. Okay, so first, what is RAD Studio? RAD Studio is the collection of many technologies that provide you with the ways to create applications for Windows, Mac, mobile, and the Internet of Things. So the technologies that I'm going to demonstrate here can be used either in desktop applications or in mobile, Android, or iOS applications. So specifically, let's go directly into JSON. JSON is a lightweight data interchange format that was created a number of years ago as a new version of XML. XML, something like 15 years ago, was very popular as an ultimate data exchange format, but over time it became quite heavy, and there was a number of technologies like XML namespaces, XML schema, that made it quite difficult and quite heavy to parse XML. So nowadays JSON is probably the most powerful and the most popular data interchange format that is not tied to any programming language, but it has mappings to most of the contemporary programming languages. So you can generate JSON in one programming environment and read it in another. So that's something very popular nowadays in the world of programmers. So JSON is based on just two structures. There is an object, which is just an unordered set of name-value pairs. So object maps very nicely to the concept of the class or object in most of the object-oriented programming languages. And the second structure that is used in JSON is array, which is an ordered collection of values. So string is a string, but the value can be very much anything. So the value is either a complex type, so object or array. So this makes it for a possibility to nest the objects within objects and arrays within arrays, arrays within objects, etc. And there are also simple types. So the JSON provides also three literals, which is true, false, or null. But also you can use numbers or strings. So string is very much like a C or Java string. It is a Unicode string enclosed with quotes with a backslash escapes. And JSON number is also very much like a C number. JSON is a superset, is compatible with JavaScript, so that's why it's named JavaScript Object Notation. So it's very easy to understand. And in fact, there is nothing more to the JSON standard. One of the interesting points in a JSON specification is that this specification is final. So we are not going to expect more complexity. So probably the simplicity of the JSON standard is one of the reasons why it's so popular and so important for programmers. So let's move into how RAD Studio supports JSON. So in RAD Studio we have two programming languages, Delphi and C++. So the technologies that I'm going to discuss today are relevant to both Delphi and C++, and also it is on a quite low level of runtime type library, which is a foundation for both the VCL framework for creating Windows application and FireMonkey framework for creating multi-device applications. So there are some new features in JSON for JSON introduced in RAD Studio 10 Seattle. So we have a brand new streaming model. So far the only model to work with JSON was through the document object model representation, where JSON was represented by a number of objects that were created within memory. Now we have much performant ways of working with JSON through streaming. So instead of building an intermediate representation of JSON in memory, which can be memory and processor intensive, we have now abstract reader and writer classes that are then extended through a number of specialized classes, like for example a tJSON text writer or tJSON text reader. There are also very interesting new builder classes, so classes like tJSON array builder or tJSON object builder, that make it possible to write JSON with code that is very similar and very easy to read. It resembles very much how the resulting JSON will look like. Also, there is a new format for working with JSON, the binary JSON or BSON, which is specific to working with MongoDB, NoSQL database that's using BSON as its internal data format for performance reasons, because working with the binary JSON can be more performant than working with its text representation. So how does this concept of JSON map into Delphi and C++ builder? So there, if you add to your projects the system.json unit or system.json namespace, there is a number of classes that represent JSON or maps JSON concepts into the Delphi and C++ code. So we have a tJSON value. Actually, on a very highest level, there is a tJSON ancestor, but then we have a tJSON value that directly maps to the concept of a JSON value, and there are some inherited classes like tJSON null, tJSON string, object, array. In JSON specification, there is no concept of bool, but it is quite logical to, instead of directly inherit from tJSON to tJSON false and tJSON true, we have an intermediate tJSON bool class. So these classes are not new to RAD Studio 10, but they are used in different scenarios when working with JSON. When you want to parse JSON, you will get inside of memory a graph of objects of this type. So this is quite basic and quite important. Okay, so going further, we have different ways of writing and different ways of reading JSON. So on this slide you can see the samples of a source code, how you could write code to output some JSON. In fact, this is exactly the same JSON. There is an object with a colors array, and there are objects for different hexadecimal representation of color. On the right hand side you can see how you would do it in RAD Studio and earlier releases. It's still possible to do it in RAD Studio 10. So there are two ways. So you can, using the old framework, you are creating objects inside of memory, and then you can then convert them to string. The new framework does not need to create intermediate objects. It directly writes to a stream, to a file, so that's it's first more readable, but also more performant. Let's have a look into some samples inside of the RAD Studio 10 Seattle installation. The first demo demonstrates different ways of generating JSON. So it's a very simple multi-device Delphi application with one memo where we are going to output information and just 3 buttons to perform different to execute different code in different techniques to generate button. Let's first have a look at the first existing way of generating JSON. So this is a technology that you could use, or approach that you could use also in the previous versions of Delphi. Basically, we are going to generate a sample JSON with some stock information. So I have some, let's maybe run it to see what kind of JSON we are going to generate. So this is a simple file with just it's a JSON object with one property called stocks, and then its value is an array that contains 2 objects for stock information. So we have a property called symbol that is a string, and another is a price, which is a number. So this is the type of the JSON we want to generate. So first approach is via DOM, or document object model. In this approach we are creating JSON objects in memory that represents our desired JSON. So on a high level we have a object stock, so we can create a tJSON object, and then within this JSON objects there is an array, so JSON array that will contain 2 elements. So we can then create in code 2 JSON objects and add 2 pairs, so 1 pair for a symbol and second pair for a price. So when this object is created, we can add it to the array, and we can do the same thing with the second object. And when our array is ready, we can add this array as a value to our object stocks. So at that moment we have an representation of JSON in memory, and we can stringify it or convert it to string using a toString method on a root level object stocks. So that's the first approach, and probably faster way of doing of writing code is this one. So we are using a string writer. So this is this class is not JSON specific. It's just used to output to string arbitrary values, and this class works with a tJSON text writer that takes as an argument this string writer. So we need to first create the tJSON text writer instance, and then we can start calling its method to output the JSON to string. So nice thing here is that we can specify formatting, so we can specify a different JSON formatting, so this could be none or intended. So that's very useful technique to make the output look nice. And we can just call different methods on a writer, like start object, start write property name, write start array, and in this way this code is much more readable. It's easier to understand what kind of JSON we are going to output. And then when we are done, we can call end object, and then we can call toString on a string writer to output the resulting string. So when I run the very first code, I will just get a string that was created using a DOM. I can use a writer, so because of the intent formatting, it looks nicely. And the second new way of generating JSON is through fluent builders. So now we do the same as we did in the previous example. We want to have just a string writer and a tJSON text writer, but on top of this tJSON text writer, we can instantiate tJSON object builder class that takes as a parameter our tJSON text writer. Again, we specify the formatting, but notice that right now this is very verbose code. We have these fluent builders that is just long concatenated call to different methods that are very easy to understand what kind of the JSON we are going to output. So even the structure of the code resembles the output, and this is a new very powerful way of generating JSON. One of the demos that comes with RAD Studio JSON Workbench can be used to play with those different technologies. So basically it's a quite nice demo that demonstrates how you can do different things with JSON. Also, it can help you generate a Delphi code based on a sample of some JSON. So let's run this demo. This demo is installed with RAD Studio 10 Seattle, so you can play it yourself. So this is actually a sample of JSON that comes from a json.org website that demonstrates just how the JSON looks like. So we can first of all beautify it, so it looks it's nicely intended. We can minify it so there is no spaces, and it occupies as little space as possible. We can also convert these to Delphi. So just in code, this, if we would execute this assignment, this block of code in the S string variable, we would have a resulting code. We can also generate the simple writer code. So this is the code that I have been demonstrating a moment ago, but based on the living example of JSON. Or you can also use builders and generate the code using builders. So this is probably the nicest and the most elegant way of generating JSON. There is also, on the second tab of this demo, we can see example of converting JSON to its binary representation and back. So you can see that yeah, it's not very human friendly, the binary representation, but the JSON is human friendly and more readable. So these are the different ways of working with JSON. So first of all, right now in RAD Studio 10 we have 3 different ways of generating JSON. We can use the existing document object model, we can use writers, or we can use fluent builders to generate JSON code. In terms of JSON writing performance, using the new framework is more efficient because we don't need to create a temporary memory objects. So we just write JSON directly to whatever medium we want, so we can write to string, to file, to a stream, and we do it directly without creating temporary objects that can be memory expensive and also processor expensive. Okay, so there is also corresponding new architecture for reading JSON. We have new reader class. So let's compare the old way of reading JSON and the new way of reading JSON. So again, in the old framework, we need to use in-memory objects. So the key method here is a parse JSON value, which is an overridden method on a tJSON object. You can pass a string, you can pass a array of bytes, you can pass a stream to this method, and then it would return a tJSON value. So the tJSON value is an ancestor of all different simple and complex JSON types. So in your code you would typically check which descendant or which specialized type it is, and then you would perform processing depending on what you have got from a parse JSON value. If the parse JSON value is not successful or it does not contain a valid JSON, then you would get a nil reference. In the new framework, we are using a tstring reader and tJSON reader, and we can then go in a one-way fashion through the whole stream of bytes token by token, and typically in code we would check what kind of a token we got in our input stream and perform different processing. Let's have a look at different ways of reading or parsing JSON in RAD Studio 10 Seattle. So we're going to work with the same JSON that we were generating in a previous example. So we have just an object with some stock values. So first of all, this is a typical code that you would write in order to parse JSON using the new reader architecture. So first of all, let's have a look what this piece of code is doing. So we are going to go through the whole JSON, and we are going to just read it token by token. So this is a kind of the output we are going to get, and it is very similar to what we would be doing when writing the JSON. So now we are reading individual tokens, and we can programmatically check the type of the token and then read a value associated with this token. So for example, when we got a start object, then we can do processing to process the whole stocks array, and then if we have a property name, we can check what is the name of the property. In this case, that would be a symbol, and in the string you would read the value of this property. In the next token we get a property name. This time this would be a price, and then we could read the actual value of this property, and then we go to the end of the object, we start a new object, and we can read the second stock. So this is a very typical and very fast way of reading JSON. So I have a simple demo here. So first I'm going to get JSON from the memo on the left hand side, and then I'm going to, when I have this JSON text in a string variable, I can create a string reader that expects a JSON text. So again, string reader class is not specific to JSON. It's used to read arbitrary string, but then the tJSON text reader is specific to a JSON class, and it expects as a parameter to its constructor a string reader. So when we already constructed tJSON reader class, then we can keep calling its read method that returns true or false. So it will return true until there is some more tokens to read, and when we are at the end of the string, and end of the our JSON, it would return false. So inside of this block of code, we can do arbitrary processing. So typically we would check for a type of a token. So I have implemented this JSON token to string method that will just go through all possible JSON token types. This is an enumerated value. You can, if you go to the declaration in the system.json.types, you can see an enumeration of all possible JSON tokens. So notice that this is more rich as compared to just a raw JSON specification. It's more tied to a type system of MongoDB that you can consider a superset of just regular specification of JSON. So this is just plain code, just one method to one procedure to convert a token to its string representation, and that's what I'm doing here. Basically just convert a token that I got from the reader and display a token type in the list box. So that's the functionality of my first button, so I can read tokens. So if you want to read JSON, then you want to convert it into some useful data structures. So before you get some JSON, maybe from a file, maybe from the URL in the internet, you want to you are expecting certain structures to be there. So what I'm going to do here, I have declared just a very simple stock class with just two properties, one symbol of type string and one price of double, just as convenient holders for data coming from JSON. So also there is a corresponding T stocks class that is just a generic object list of stock instances. So my goal in reading JSON in this demo is to convert JSON coming from a string into a list of stock objects, and I have also implemented implemented method that takes stocks and display them in the memo. So if I do the processing or reading of JSON using the new and the old way, then I will pass these resulting stocks for display, so I can see how many stock instances I have and what are their properties. So there are two ways of reading JSON. So let's maybe first start with the old way of reading JSON. So using an in-memory objects. So first I'm going to create a stocks instance as a holder for the processed values, and then the very first call that I need to make is to call parse JSON value. So this parse JSON value, if we jump to the declaration, is an overloaded method of a JSON object. Is a class function, so we don't need to create a JSON object to call it, and we can pass either data or an array of bytes. We can specify an offset, so we can start parsing from a certain place within the JSON string. So this is the method that is a starting point for reading using DOM. So then we get a val system tJSON value. So we want to first make sure that it's not nil. So if there was, for example, some malformed JSON, we would get a nil value, but hopefully it's not nil. And then we want to check if it's an object. So again, we are expecting certain structures to be there, otherwise it would be very difficult to process it. So we check if this val root is an instance of a tJSON object, and if this is the case, we can perform a typecast from a JSON value to the JSON object. So from this moment we have access to different properties of the tJSON object, like for example count, a number of pairs that it contains. So we know that it will contain just one property called stocks. So that's what we are checking. So we first check if it's more than 0, and if it's more than 0, then we just try to read a value of a property called stocks. And again we are getting a tJSON value, and we are expecting this to be a tJSON array. So if it's not nil, we are checking if it's a tJSON array, and then we can typecast it to the tJSON array, and then we can perform processing on each element of an array. So we have a loop here that goes through all the elements of the stocks array, and to make it more readable we have this process stock object method that takes stocks. So this is our holder for all the stocks, and also the particular JSON object that contains information about the certain stock. And this is what we do in code. In this loop we create a stock instance, and we go through the different properties that we expect to find there. So first we try to find a property with a type with a name symbol, and we know it's a string. So if this is a string, we can assign to a stock, and we do the same thing for the price. And when we are done processing, we can add our stock to the stocks parameter that was passed through the parameter. So in this way we can go through all the properties, all the objects, and if we run this application, it's still running, we can just read our JSON using DOM approach. So I have this date here, so I'm expecting the very same output from the reader, so that's why I'm checking the date, changing the date. So the second approach, the new approach for reading JSON, is again faster and is using streams. So I'm creating stocks holder or stocks array for storing the resulting stock objects, and we create a string reader, and based on a string reader we create tJSON text reader, and we inside of the loop we are processing each token, and we are actually interested only into the places inside of our JSON stream that are start of the object. If this is a start of the object, then we try to treat it as a stock and add it to this stock reference, and at the end we just display stocks and free the stocks reference when we are done. So this is the code. Actually there is more to it, because if we process stock, how do we go further? So we pass as a parameter a tJSON text reader, we create a stock again, and this is important to see that we are now, this is the same reference of the same JSON text reader. So calling read basically moves us further in the stream. So we keep reading the stream until we get a property. That's something we are interested to extract, and when we call, when we are at the level of the property called property name, we just check if this is the right property, and we need to make another call to read to advance one token further, and then we are expecting to find the value of our symbol, and the same functionality for extracting the value of the price. So if we get to the tJSON token end object, then we are finished processing this particular stock, and we can add the stock reference to our stocks collection and exit this method. So this is a more powerful and faster way of reading JSON, and obviously it just gives us the very same output. Similarly to writing JSON, using the new framework for reading JSON is better or is faster. Sometimes it's still a choice of the programmer how he or she wants to read JSON, but with the new framework based on streams, we directly read JSON and we process directly each token as they come from the input. In the old way, the document object model way, to read JSON, we had to create a lot of memory objects, which can be more expensive in terms of memory consumption and processor power. Okay, as the last part of this presentation, I'm going to demonstrate two different custom components that I have wrote. In fact, almost 5 years ago, when JSON support was introduced to Delphi, but now I have refactored them and upgraded the code to the latest units and made it more powerful. And these two components are working together. So the tJSON document was actually modeled after the tXML document, that one of the components that were there in Delphi probably since Delphi 6, that just encapsulates a design time and instance of an XML document. So now I thought it makes sense to create a corresponding tJSON document that encapsulates and make it possible to manipulate at design time JSON information. So the tJSON document component is independent of any user interface, so it can be used in either VCL or FireMonkey application. It encapsulates this functionality to build an in-memory object, in-memory graph of JSON objects. So when you assign to a JSON text, it will call a parse JSON value, and you can then access the object model of a JSON document, and then that's what the tJSON TreeView component is doing. So tJSON TreeView component is VCL specific because it's a descendant of the Windows TreeView component, and it works with a tJSON document. So it has a JSON document property. When you hook the two components together, then you can display contents of a tJSON document in a handy tree, which makes it possible to understand the structure of JSON. So in the previous example, we have seen that when you are parsing JSON, you really want to know what kind of structures you can expect there, so you can build your parsing code in appropriate way. So as an example of using these components, I have also created a JSON viewer utility application that I'm using quite a lot on my own when I want to work with some JSON that is new, is coming from an unknown source. Before I can write code to parse it, to read it in memory, to export it to the database, I'm using JSON viewer to understand the structure of a JSON. So with JSON viewer, you can take JSON and load it from the URL from a file in your file system, or paste from a clipboard, and you can very quickly see the structure of this JSON. Let's have a look at two Delphi 10 Seattle custom components for working with JSON. There are two components: tJSON document component that inherits directly from a T component, and it provides a way to parse JSON text to a JSON value. So when you assign to a JSON text property, you will get a JSON value read only property, and you can programmatically traverse the different JSON objects that are created in memory that represents the JSON text. So this component works together with a JSON TreeView component. So the JSON TreeView component is a descendant of a VCL Windows TreeView control, and it has a tJSON document property so they work together. When you hook these two components together, you can visualize the contents of the tJSON document component in the user interface. So this source code of these two components with the corresponding design time packages is available for download. You can just select and build them all, and here in the install on the design packages you want to install these components, and after you have installed these components you should be able to find them in the list of installed packages. So in my case these are these two components, so JSON document in one package. So this is two different packages because JSON document can work with VCL and FireMonkey, and the JSON tree view component can work only with the VCL. Okay, so let's have a look how you could use these components. I'm going to create a new application, new VCL forms application. I'm going to drop a tJSON document on the form. I have already made it easy for me and take some JSON that we have created earlier into the clipboard, and I can copy and paste this into the JSON text property of this component. Okay, so now I can take another component, JSON tree view component, put it on the form, maybe make it slightly bigger, and connect the JSON document component through the corresponding JSON document property. So right now we can see our JSON information nicely visualized in the form of a tree, and you can the tree view component also has a properties to also control if you want to see the number of childs of different objects and arrays, and also the sizes in bytes of different nodes in the tree. Okay, so based on these two components, I have created a JSON viewer application. So this is a simple VCL utility application that lets you load into the tree view. So we have our tJSON document, we have our tJSON tree view connected together, and you can load JSON from either a clipboard or from the file or from the URL. Especially this last option is useful, and for this I'm using the new HTTP client library part of RAD Studio. So this is actually this unit with two HTTP client and HTTP request components that make it possible to load JSON from any place that is accessible using HTTP protocol. Okay, let's run this application and have a look what it does. So it's already, I believe, running. Now I need to copy the right inside of the project options. So project options, I need to go and select a different icon because this one couldn't be found. So let me very quickly fix this one problem. I can copy it, and now it should compile nicely. Okay, so now I have I can paste the JSON from the clipboard because it was still there. I can load JSON from a file. So again, it's just the same stocks, but this time read from a file. And I can also read JSON from the internet. So imagine the situation where we have where we want to, for example, integrate with some JSON data that we don't know about anything about their structure. So before we can do anything, you can use JSON viewer to display JSON in more readable format. So an example of such an JSON that is available online is the Amsterdam open data. So the city of Amsterdam makes available all kinds of information that developers can use to integrate into their applications. So for example, on the data.amsterdam.nl there is 199 data sets available in different formats, also the JSON formats, and we are going to have a look into the touristic and culture information. We can see what kind of information we have available in JSON format. So this is information about shops, about the activities, festivals, attractions, eating and drinking, all kind of interesting things. So let's have a look into the information about activities, what you can do in Amsterdam. So activities JSON, you can see this is the link to the JSON file, and if you open it, it can be kind of difficult to swallow. So you want to have a tool to make it more visible. So that's what we are going to do. I'm going to take this URL here, and I'm going to use it as part of my my demo. So I'm going to put it into this link and click on load from a URL, and I have loaded something. So I have loaded 111 information about all kinds of activities, and then you can see that these activities, they have a similar structure. So when I would think about parsing this JSON, I know that I would probably need to create a reader code to go through all activities and create an activity record based on a similar structure in each of the files. So this is something I'm using quite a lot. In fact, you can just compile this application, add it to your tools, and use it as part of your daily programmer work. Okay, so that's it for this presentation. I hope that you find it useful, and it's now time for live questions.
There was a question about whether you could take the 10 Seattle and extensions for JSON, the new things, and try to compile them on older versions. We have not tried that. You could try it yourself. I'm not sure all the dependencies. We haven't backported the JSON as far as I know. Have you heard anything, Jim? I haven't seen it backported to older versions, and I haven't seen anybody try.
Yeah, I know that we have that. I believe there's an update that has some features backported, but I don't know if that's in there or not.
Yeah. So try it yourself. That might be cool. There was a question about. Let's see. It was
Welcome to learn.
Okay, it was saying surely use the builder version. You're fixed in code. How can you make this dynamic? I wasn't sure what that was actually doing. I mean, there's things you can do in code, and there's things you can do using some of the components like the REST components and so on. Data snap components, live bindings, and such that you can do at design time. So the questioner has left, so it's not sure if he hasn't replied back. So, but again, we have some capabilities you can do at design time, and there's some things you can do at runtime in code. You can always query and in a sense do dynamic generation of objects. You'd have to do that in code. There was a question about, is there a T-object to JSON converters, and I put the link to serializing user objects that relates to datasnap/JSON if you want to be able to serialize different parts of the JSON into actual objects. I mean, Pawel talked about a project that's out there for, specifically for Delphi objects, but the general notes on that Glowacki link that I put in are available. What are the names of the units for the old and new frameworks? I put the links in the Q&A for both the Seattle version of the documentation for system.json, and I put the exe8 URL for system.json, so you can put those in a browser side by side and look at them and see the differences. You can also, if you have exe8 and 10 Seattle, you could open up the system.json unit and look at the source code side by side. We don't have a document that I know of specifically, other than in the What's New, it talks about things that are new in 10 Seattle for JSON, and I put that link in the Q&A log as well, the What's New JSON improvements. Is there a JSON viewer for C++? There's a couple ways to look at JSON. One is you can use the REST debugger, and the REST debugger lets you view JSON in both just the JSON format, but also you can connect it to a grid. At the bottom, you can have a grid view of a selected node in the JSON. So that's one way. How do I find an object in JSON? You can look for the name. Other ways besides looping through all the items, I don't know of any other indexing way. I mean, there's no sort of table of contents for JSON.
Well, that's one thing that's different. If you've used the DOM in XML before, the DOM gave you this ability to like look at the whole document as a whole. JSON, you don't have that. With JSON, you have to browse through it, and so it's a little different because you have to go through it linearly, but it makes it for faster and less memory consumption.
Yeah, there's no dictionary that's at the header of the JSON for like some index inside of it. You can look at how if you have 10 Seattle or Exeate or whatever, look at the source code of the REST debugger that we give you, and that'll give you one way of seeing going through. We got a problem. Okay, if there's a problem, Yusuf put an entry in Quality Portal, quality.embarcadero.com. If it's just in a sample, then send us an email. Send me an email, and we'll make sure we fix the sample.
So there's a question here about how to use binary data, for example, images in JSON. So in that case, you'd want to base 64 encode it, just like an XML.
Yep, exact same thing. Let's see, easy way to convert a data set to JSON similar to T-client dataset XML data. FDMemTable allows you to save what's in FDMemTable as JSON. You can also use, again, the serialize objects link that I put in before. So that's FDMemTable is probably the easiest way. And then there's a save to, and you specify the format. So check out FDMemTable. It's a great in-memory data set, very similar to T-client data set. It doesn't have aggregations or filters in that respect, but you can do all sorts of query operations on FDMemTable. So that's really probably the best way is FDMemTable. If you're already, again, thinking or using T-client dataset. Combining with PHP. Well, whatever your PHP is doing on the side, on that side, if you've got PHP on a Linux server, if it's, if the PHP, and there's plenty of PHP code for taking data sets and creating JSON, and then the JSON can come into your Delphi or C++ builder app. So should be easy to do. Has the new way been implemented in the web service components and improved performance? Not that I'm aware of. I don't know if like DataSnap is using the new JSON. I'll have to check if it's using some of that under the covers.
I know there's been some improvements. I'm not sure if it has all the latest stuff in it though or not.
There's a question here, Jim. Maybe you have some thoughts. Could you please explain in more detail the concept behind streaming JSON? No need to create temporary memory objects, etc. Did you see that one, Jim? Down at 6:52 a.m. Uh-oh, did I lose Jim?
Sorry, I muted myself.
Oh, there you go. Question here. I'm not sure if you see it.
I see it there. I'm not sure exactly what the context is there, but if you're streaming it like over HTTP, it's just a matter of transferring it. I guess you could, in theory, be generating the JSON as you're transferring it and just writing it out to a, if you like an open socket, you could be writing the JSON straight to the socket and then just close it up when you're done. But most likely you're going, unless you have like a incredibly large document or a document that's not completely generated yet, you're going to just generate the JSON and then write it to the stream.
Okay. Is there an easy way to read stringless text into a JSON structure? Oh, do we have a string list to JSON? I have to go back and...
You can, I'm trying to look up there's a method where you can just take a string, whether it came from a string list or whatever, and switch that into JSON, but I don't know where it is real quick to try and look it up.
There is a tJSON string that is a class for creating a JSON string. Let's see.
Yeah, so that's what you do. You just put the string into there.
Yep. Now let me put that link. Making time to JSON. Let's see. How can we get different date time? Well, you could use the format date time method to create the string for the format date and time that you want. And then
I actually looked into this a while ago. I don't know that there's an official agreed upon format for what date and time looks like in JSON, because I've seen it a few different ways. I've seen it as an integer and I've seen it as like UTSC time. So it's just a matter of whatever format you're agreed upon, and then just convert it to that using like you said, date time, format date time.
have different date time format standards. I mean, in Windows you can set what the default
and there's
is.
I think in the date time utils there's a like
personalization or preference you can set for Windows, and then you can cover that. But that broke up, Jim. Can you repeat? You broke up during that comment you just did.
Oh, yeah. I was just saying that the date time utils has some good utilities in there for converting different standard formats and stuff. So I think there's like a UTC time or a Unix timestamp function in date time utils that you can use.
There's several. I mean, you can search online for JSON and dates and times. Here's one link back from 2011. Let's see where, because there's like an ISO date time. What is it? ISO 8601. And then different languages do different things. So
yeah, it really depends on who's going to consume your JSON or where you're getting your JSON from. And because I don't think there's a standard way. Because for example, if you're writing it to be consumed by JavaScript, you're probably going to put it in JavaScript common notation. If you're writing to be consumed by a Delphi app on the other side, then write it whatever's most convenient. So it really just depends on who's consuming it from the other side. Yeah, yes, ISO standards. Ideally, you should use an ISO standard for the date time, but
we agree. Everybody should use the ISO standard. But then there may be legacy code out there. I don't know. Question about taking systools tree to JSON. You can try it yourself in code. The only thing I know, I don't know of any, when you have other components and other formats for data structures, you'll take a look at the samples that we have for serializing objects into JSON and write some code, and then give it back to the systools project, give that tree to JSON converter that you build, and share it with everyone. Let's see.
So there's the, I just put a link in there for the date to ISO 8601 utility and date utils that will convert date time to ISO 8601.
Yeah, I can use that on both sides or whichever side you're building.
And then there, if you look at the C also, there's an ISO 8601 to date. So if we're going back.
There's Robert was putting in that the builder approach is not so useful when needing to deal with arrays that have variable number of elements. Not that I'm aware of. Other, you saw Pawel go through 110 or 111 items. You just have to get to the right JSON endpoint node, and then if it's an array, then you can go through and loop for the count of the number of items in that node and pull them out. So I'm not aware of any limit on arrays.
Well, I think he's talking about the different ways of constructing JSON, whether you're using the JSON builders or not. I'm trying to think. I can't say for sure offhand, but if you looked at it, if you try it, it probably makes sense for you after a little bit.
There was a question more asking for links about having JSON and OAuth2 solutions and so on as it relates to what we provide as alternatives to Parse. Parse is owned by Facebook and is shutting down their backend as a service system, APIs, and so on. I blogged about that a while ago. They're going to give you source code and you can build your own thing and so on. But we still have backend as a service support with JSON support in our enterprise mobility server, EMS. We still have backend providers for Convey and App42 by Shep Hertz, Hertz, SHEP. We also have examples for OAuth2, and Brian Alexakis did a skill sprint on OAuth2. And I put the link to Brian's blog post for skill sprint, which has the replay link and links to documentation and samples. Jim, you did something back in 2014, and Code Rage, we have different links. So I put the link to delphi.org, how to integrate cloud services with REST and JSON from the client side. And I put the doc wiki for the REST client library, which talks about what you can do with the components and REST and JSON. Also, I put in doc links for the backend as a service overview doc wiki, as well as Serena DuPont, product manager for RAD Studio. She did a whole series of BAS tutorials, especially for Convey, some for Parse, but also for Convey about object storage, user management, device management, push, and so on. So those links are in there, Sebastian. And then I put the doc wiki link to our EMS server. And then I just created a blog post. The next webinar in this quarter's series is March 17th. I'm doing on building enterprise business application with REST and JSON and the EMS enterprise mobility services and push and all the features, user management, groups, and so on. So a lot of links there. Let's see, anything else? So I talked about the REST debugger. The REST debugger you can use as a great way to spelunk through REST services of all kinds, including those that return XML or text or JSON, and then you can look at the JSON and then look at the JSON in a grid view as a data set. When you select a certain JSON node, you can pass parameters. It supports the authorization. If you have to provide that, you can do that. So check out the REST debugger. I didn't put the link to the REST debugger.wiki. I'll put that one in there. That's included. I think it's been included for several releases now, at least XE7 and XE8, and it's part of 10 Seattle. You'll find the binary either linked off the Tools menu in the IDE, Tools REST debugger, or you'll find it in the bin folder, and we also give you the source code. And it uses the REST client library components and code underneath the covers. What else about the REST debugger, Jim, while I find the REST debugger?
So there's a few questions here about the downloads and replay, and those will be made available at the URL you see on there from Pawel's blog will be updated with the replay and downloads shortly.
Well, I just need to put up the link to my PayPal account. I always threaten to do that, but I never do. All right. Here I'm going to put the REST debugger link on that comment about the REST debugger. Oh, where'd it go? There it is. Yes. It's almost the same as REST debugger. I think the difference, the REST debugger is a turnkey application that uses the REST client library components under the covers. What Pawel showed you was how to do it in code using the JSON classes and the system.json Delphi unit. I'll make sure we have C++ samples that would use the system : JSON namespace for C++. All of that is available. The documentation is there, and we'll make sure the links get put into the Pawel's blog post, as Jim mentioned, the one on the screen, for all of this stuff. And yeah, demos and components, download the session. Again, the replay, once we finish the 5 p.m. time slot, will get put up on the Embarcadero YouTube channel, and you'll find it up there. We'll put the link to it, again, as Jim mentions, in Pawel's blog post, and turn that in from a registration blog post to more the landing page on his blog for all the materials that we have. And for what about parsing JSON where names aren't surrounded with quotes?
You know, I think it will handle that as long as there's no spaces in the name. It's fairly flexible. It seems like I remember we were working that way, but typically you do want to have quotes.
There was a conversation earlier, I think, in the 6 a.m. hour about dates, times, and I think the advice was use the ISO standard date time encoding, and then you can convert date time into a JSON string and then convert it back again. But if you're trying to do interoperability with PHP and all sorts of other kinds of JSON services, ISO date time format would be a great thing. We'll get that link. Jim, you posted it.
Yep, I'll put it right here in the chat window.
So put it in the chat window. We'll get that into the blog post as well.
And really, for dates, it comes down to who you're sending it to. But yeah, usually 8601 is the way to go for dates. JSON within JSON. If you want to do that, you're probably going to want to use base64 encode it so that it doesn't come out as JSON. It really depends on what you're trying to accomplish with that. Although you could use URL encoding or something like that as well.
Yes, do we have a PHP example? I don't do PHP, although we have HTML5 builder. But we've given demos where we've talked to all sorts of REST servers that return JSON, and we don't know what they're programmed. They could be ASP.NET, they could be PHP, they could be something else. Our DataSnap also has the REST server wizard, so you could build your own using the DataSnap technology if you have the Enterprise Edition and above. So I don't really usually worry about what's on the back-end side, but I'll try to find, see if I can search to find some PHP sample server REST JSON source code for server side and put it on it. You know, if somebody knows of one or can search as well, just post an answer, post in the chat window, or put a question in with the link, and we'll share it with everybody.
So there's a question here about the said that XE7's JSON implementation was sensitive to more sensitive to errors in the JSON encoding. Now, I haven't tried the specific errors you're referring to, but when I have worked with the JSON encoding in 10 Seattle, I found that it was a little more robust. Like I said, I didn't test those specific errors that you encountered, but the experiments I did with it, it was able to decode things even though they weren't always exactly like expected. So probably, but you know, like I said, I haven't tried those specific errors that you've referred to.
Is it better to use JSON writer or binary writer, which is faster?
Probably they're comparable. If binary writer might be faster just because it's moving less bits, but it's probably comparable. It could be in some situations one might be faster than the other. I would suggest making a test to test in your use case scenario to find out which works best for you.
I know there's some people, thinking about this, Jim. There's ways to, with JSON, some people are compressing the text, right? I think they're compressing the text, but then they have the decompressor on either side, right, for your own kind of applications. Is the HTTP component used using the new, everything that we're doing now does not use Indy. So whether it's the EMS server, DataSnap server, JSON, anything that other than an Indy-based application, is using the native HTTP under the covers. Cloud API, everything's been changed. Except, again, if you have an Indy app, like I have a sample that I use, which is a send mail, SMTP component. I use the Indy component there.
So there's a few questions about how to encode different types of data. Anything you want to send via JSON, you can. You can send an image via JSON if you base64 encode it. If you're sending it to your app on the other side to consume it, then it doesn't make any difference how you encode it. You can, encode it however you want to. You can encode it, whatever you want to use, as long as both sides agree on. Now, if you're sending it to a web service, you need to go to the web services documentation and find out how they're expecting dates and encrypted data and file paths and stuff to be sent to it. Now, if it's expecting that you replace quotes with apostrophes or something, whatever it is, whatever they're expecting, you need to make sure you follow that encoding. If you're sending in, you control both sides, or you're setting the spec for both sides, then you can use whatever encoding you want to use, whether it be base64 or whatever. So it really depends on what the other party is expecting for how you want to encode this stuff.
I was on this other one about, what about BizTalk server? I don't have a BizTalk server. If it does rest in JSON, then it should work. But I'll have to find a BizTalk server running somewhere and connect to it. If somebody's got a BizTalk server, I can use REST debugger and do some other things with. Send me an email at david@embarcadero.com.
So there's a question here about the functions to query JSON with selectors like jQuery selectors do. I don't think there's, oh wait, you know what, I think there was I can't recall what it was though, there was a way to search through it. One note though about that is that it does require a linear search, and so if you're dealing with a larger JSON document.
I'm just saying if anybody needs additional links, or you're not sure with the links we provided, if it gives you what you need, just send us an email. I'm david@embarcadero.com. Jim is jim.mckeith, M-C-K-E-E-T-H. And we'll just add links and notes to Pawel's blog. That way it's all in one place. But I'll also reply on email and send you links. That way we capture all of that stuff and put it in context with this webinar. So, yeah. Okay, suggestion about RTTI and C++ builder. Okay, we'll add that. There's some things you can and cannot do with C++ builder as it works with Delphi, and we have sessions. You might go to CodeRage 9. There's a session about C++ builder in an Object Pascal kind of world by Bruno Babet. Just go to CodeRage 9, the C++ track. I think it was on the third day, on the Thursday morning, CodeRage 9.
So the question, if we plan to support JSON 5, I don't know. If you go to quality.embarcadero.com, you can certainly put in a feature request if that's something you think we should support. Provide details in there as to why we should support it, and the product management will evaluate that. So the question here, if it can output JSON in UTF-8 format, because the tjson objects.toJSON escapes Unicode characters. So I was actually reading about JSON, and according to what I was reading, it said that you should escape Unicode characters when you're writing into JSON. So that's actually correct, that it escapes Unicode characters. There may be a way around that, but depending on what object you're using. So check out when the source code's available, check that out. He showed the different ways to write JSON documents. So you could try the other method and see if that works, and there may be an option there for it as well. But from what I read in the standard, it was they're supposed to escape Unicode characters. It said you can do it without escaping Unicode characters, but the preferred way was to escape the Unicode characters. Now, again, a lot of this depends on who you're exchanging data with and whether they want them escaped or not. Likewise, for example, you're supposed to put quotes around the names for the name value pairs, and I've seen it. Sometimes you get JSON without the quotes around the names in it. Usually, I know that you can read it without the quotes around the names as long as there's no spaces in the names.
One of the things we always tell people is you can use the REST debugger to Splunk servers you want to talk to and see what's coming back. So, the REST debugger is included with at least exe7, exe8, and 10 Seattle off the tool menu in the IDE, and the binary is in the bin folder. So just look in your hard drive for the REST debugger, and you can use that to point to different servers and see what comes back, see what the JSON looks like, see what they provide.
So it says I'm processing a JSON string. I get an object that I want to pass the JSON for that object to a class to decode that object's parts of the JSON. Can I do this easily? I believe so. It depends. There's different ways Pawel showed to read the JSON. But yeah, you can trying to think the process for that.
There's a Glowacki page for streaming. Let's see, what did I do that before? Serializing user objects, I think, is one of the pages. But again, you can go and look at system.json. That's the top level unit in the runtime library source code. If you have the Pro, Enterprise, or Above edition versus the Starter edition or the Trial edition, which doesn't include. Here, let me put the serializing user objects link in there to take a look. You can always, there's a question here about, could you build dynamically by knowing the form of JSON objects you are getting? You can. I mean, you can query and look at the JSON yourself. There's no, REST servers that return JSON, they don't tell you any metadata unless part of the JSON they would send back might give you some metadata as part of the JSON stream, and then you could, if the server you talk to does something like that, then you could use that to do dynamic programming on what might follow. But most servers I've talked to REST with JSON, they just send you streams of JSON. They don't sort of self-document themselves, at least as far as I've ever seen. Have you seen anything?
Right, yeah. OData has kind of a metadata in there. It's based on JSON, but it has a metadata in there. But otherwise, I've never seen metadata in JSON typically. Like OData is the only time I've seen that. But yeah, it's easy to have your reader, when you're reading it, query and say, what elements do I have here? Do I have these elements? Oh, I do. Okay, let's do this. And kind of intelligently decipher it, as much as you want to code it in there. So you can code it either to say there's always this element here, or test to see what element's there and then deal with it one of these ways. So there's quite a bit of flexibility in the way it works.
Yeah, if there's no documentation, sometimes people will give you a link to an HTML page or something on their REST server that gives you documentation about what they're going to return and what parameters you might pass. We've got some blogs and some videos we've done where we talk to different REST servers and get their JSON back. If I don't know and somebody says, hey, here's a REST server, I use the REST debugger. And I use that to Splunk and kind of identify what it looks like I'm getting back based on it. Best practice is most REST servers will point you to some kind of API documentation for the REST service, because again, REST and JSON, there's no, other than get, put, post, and so on, there's no definition of what they might return or what they might send. So that's why the REST debugger lets you specify parameters, authentication when you're calling a REST server, and then you can look at what comes back either in text form or in JSON, and you can even go down in the REST debugger and see the JSON kind of as a data grid with headings and with the data rows. So you can use the REST debugger as a good sort of sleuthing tool. And there are other ones like it, JSON inspectors, but
like the one Pawel showed there, that's really useful as well to be able to look at the JSON and figure out what it is and such. So yeah, that's definitely something I'm going to add to my tool belt.
Yep.
Well, I think that's the end of our questions. Thank you, everybody, for joining us. Appreciate all your questions and all your attention, and look forward to seeing you online with our future webinars.